Now, here I want to continue our conversation on average of a random variable or expected value of a random variable and talk about what does it fail to tell us. Essentially, I want to focus on an example where we have two random variables that have the same expected value. Are they behaving the same? Well, let's take a look at this example. Here we have two random variables, and they are precipitation level in two different cities. And the average of these two random variables are the same. It's 4 inches. In Seattle, it's ranging between 1 to 8. And in Miami is very consistent. It's always 4 inches. Well, here you can see the issue of only looking at expected value. If you only look at the average of these two random variables, they're the same, but they do not behave the same. Seattle is much more variable, right? And that's why we want to talk about variance and standard deviation. These are two measures to quantify variability of a random variable. So, what is the notation for variance? For variance, the different notations are typically being used. V of x, or var of x, or sigma squared of random variable x. These are different notations that you might see. And what's the definition of variance mathematically? Well, variance of x is equal to expected value of the difference between x and average squared. Well, that might be a little hard to understand at this point, but we're going to simplify that and get to a better formula to use. But the more important thing that we want to talk about here is the definition, and that is it's a measure of dispersion or scatter in the possible values of random variable x. So the more variability implies that more observations are farther from the mean, and therefore variance is going to be higher. So higher variance or standard deviation implies that you have a larger level of dispersion or scatter in the possible values of that random variable. Now, how do we calculate that? Well, the easier way of calculating variance of any random variable is expected value of x squared minus expected value of x squared. Calculating averages or expected value are easier, and that's why we're going to use this formula. But there's a big difference between these two terms. This is average of x squared values, whereas here this is average of x values then squared. So keep that in mind. That's a big part of calculating variance. How do we take the average of x squared values? Well, you follow the expected value formula that we talked about earlier, but instead of x, you have x squared times the probabilities minus expected value of x squared. Well, we already know that expected value of x is the summation over x values, x times f of x. And this is how you calculate variance. Well, we mentioned standard deviation. What is standard deviation? Well, standard deviation is very much related to variance. The notation for that is sigma of x, which means in order to get to the standard deviation, you just need to take the square root of variance, right? Or if you're using other notations for variance, you just need to take the square root of variance. The importance of a standard deviation is if you calculating the variance, it's hard to relate to that value because everything is squared. Let's take an example. If your random variable x is the time between customer arrivals, the unit of measure of that might be minutes, right? But then when you calculate the variance of x, the unit of measure of that is going to be minutes squared, which is really hard to relate. So that's why we calculate standard deviation of x, which is the square root of variance. And then at that point, we're back to unit of measure of minutes. So that's why it's easier to relate to standard deviation when you are talking about a specific random variable, and you'll see that. But they both convey the same message. The larger the variance, the more variability and dispersion. The same interpretation is true for standard deviation. The larger the standard deviation, the more dispersion and scatter of that random variable. Let's take a look at the same example that we had. And this is the worker example where here we have the PMF function, and the random variable x represents the number of tasks being done correctly by that worker. And the number of tasks can change from 0 to 4, and the probability of them getting done correctly are given in the PMF. And now we want to calculate the variance of this random variable. And the way that we calculate variance is expected value of x squared minus expected value of x squared. So here I want you to pause the video and give this a try. We already calculated the expected value of x. We know that. And you know how we calculate it. So almost half of the calculation for variance is now done. You just need to do the other half and calculate the variance. Now let's start by calculating the easier part of this, and that is expected value of x squared. Well, in the previous example, we calculated the expected value of x, and we got to 3.63. So what we can say here is that this is 3.63 squared. Well, let me go back to the previous example. Let's imagine that we want to calculate expected value of x squared, and therefore we need to do x squared times f of x. Well, what that means is that I need to square all these x values, right? So the first terms stay the same. It's 0 times 0.02. The second term stays the same, 1 times 0.03. But starting from here, it's going to be 4 times 0.05. And here, 9 times 0.1. And also here, 4 squared. And that would be 16 times 0.1. Once you do the math, that will be the expected value of x squared. And in fact, that is equal to 13.93. Well, let's go back to here. So if this is 13.93 and this is 6.63 squared, then when you do the math, the answer is 0.75. That's the variance of this random variable. What is the standard deviation of that? Well, standard deviation of this random variable is square root of 0.75, and that is 0.866. So I hope this video helped you to understand the meaning of variance and variability as opposed to mean or expected value of a random variable, and also how we calculate them.